Welcome back yet again to Physixify. We were doing something in the previous session. We were talking about the theory in equilibrium. So we are continuing from where we left off, but this time around we have some questions for you. So this is problems #1, the first session in which we would like to see how different questions are put up as far as equilibrium is concerned. Let's try to go in deeper and try to understand these problems. Question number 1. What does it say? It says that you have a function given. The function is for potential energy. It says that u is given as x square minus 8x. Only information being given to you, and then you are asked something. What is it that you are asked? You are asked to find the position and type of equilibrium. Now one thing that I understand is equilibrium means that net force should be 0. Can I relate F net to U? I've already learned that I can use that to get the position of the equilibrium, but to understand the type, I hope you are acquainted with the double derivative as well. In case you aren't, don't worry, because the questions that I have for you will make it very obvious for you. So let's talk about the first thing. If we talk about the position, what we say is that the net force must be equal to 0. This in turns means that minus du by dx should be equal to 0. And once you want to differentiate this u, in fact, what will you do? You will say x square will give you 2x, 8x will give you only 8. So your minus du by dx will turn out to be something like minus of 2x minus 8 equal to 0. Voila! We have our position. Can't you see? I think you should be able to, because this simple linear equation can yield x equal to 4. You have successfully captured the position, the first part that was asked in the question. What about the second thing? What about the type of equilibrium? So what I would do here is, like I told you, I would take the double derivative, judge this double derivative and get the answer. So if I differentiate du by dx, once again if I do d2u by dx2, I will find that x square was 2x. 2x will in turn give me only 2. So d2u by dx2 turns out to be 2, which is a constant, but the more important thing is that it is greater than 0. And you already know that if the double derivative of u with respect to x turns out to be greater than 0, you say that in this case your potential energy is minimum, or you can alternatively say that this is a stable equilibrium. So both position and type we have successfully achieved. But the questions might not be this easy every time. They might be of a little higher level. So let's talk about those higher level questions. If we talk about question number 2, this time around you are again given a u, but it's a little different. In place of a square, now the highest power that turns out is 3. U is given as 12x minus x cube. You are asked the same things again. So the process remains same, although this time you'll have to work maybe a little bit harder. Let's see how things turn up. The first things are very easy. Position, you know that f net equal to 0 is something you need to put. You put minus du by dx equal to 0, and once you differentiate, you'll get minus of 12 minus 3x square, because x cube will differentiate to 3x square, this equal to 0. Now again I would love to say voila, the position is here, but it's not, because this time around if you see you have a quadratic equation. Some people will make a mistake of taking only one answer over here, and that would be the end of the question. That is where you will falter. So this is the most important step, the next thing that comes for you. And you will say that if I put 3x square equal to 12, I should take both the values. If you'll see, x square would be 4. So x could be plus 2 as well as minus 2. So do not forget minus 2 here. Some people only take plus 2 and they find the position, and then things become, you have only half the answer. Why? Because there are two positions of equilibrium, you need to find both the types. So let us say I go in with one type, I'll take x equal to 2 for first type, x equal to minus 2 for second type, and I can get the answer. It's not that difficult, it's just a little lengthy. So I will say that if I want to get the type, let us say I'm first taking at x equal to plus 2. In this case, I again find d2u by dx2. That is double derivative of u with respect to x, I'll find out that it comes out to be minus 6x. Why? Because that 12x is gone. Minus x cube differentiated gives minus 3x square, and I differentiated again, it gives me minus 6x. And as soon as I put x equal to plus 2, I get minus 6 into plus 2 equal to minus 12. So that is why this d2u by dx2 turns out to be minus 12, which in turn, more importantly, is less than 0. Now whenever it is less than 0, you say that in this case u is maximum and that this is a condition of unstable equilibrium. The next thing that I can say over here is that this is only half the part of the question, because x equal to plus 2 if you took, why are you leaving out minus 2? Let's talk about minus 2 now. At x equal to minus 2, what will happen? You will again say that let's calculate d2u by dx2. It would be same minus 6x. The only difference being that this time you have to put x equal to minus 2. This means your d2u by dx2 turns out to be plus 12. So you see that this is like a variation of a question that you can get two different positions for just one question. But anyways, more importantly for us here, the double derivative turns out to be greater than 0. And if it is greater than 0, you know that u is minimum in this case, and you must say that this is stable equilibrium. So both the types of equilibrium you are able to get, and if you want to modify this question, maybe you should say find the positions and types of equilibrium, because there are two. But the question will never be given in that way. You'll have to see whether there are one or more than one and judge for yourself. Right. So here's a very splendid question that I am going to give you as a homework. Question number 3 says that u is given as x cubed by 3 minus 4x plus 8. Again a cubic function. You have to again find the position and type of equilibrium. The only help that comes in from my side is I'll write down the position as f net equal to 0, minus du by dx equal to 0, and then you figure out what is x. Maybe x has 1 value, 2 value, 3 value, I don't know. You need to calculate that, and then similarly you need to do the type as well. Whether it's only at x equal to something, maybe there are 2 x's, you'll have to find twice. If 3, you'll have to find thrice. That is up to you. You have to judge whether u is maximum, u is minimum, d2u by dx2 is greater than or less than or equal to 0. Do let me know whatever answers you get in the comment box, and I would be making sure that I respond to you so that you get your learning done right. That was all in this first problem session. Thanks a lot for watching this. If you have any problems, any doubts anywhere, do not hesitate to write it down in the comment box. I will make sure that your doubts do not go unanswered. If you loved this class, please make sure you do subscribe so that you don't miss out on the next problem class. And also, if you loved it, you can like it and share it amongst your friends so that everybody that you know of enjoys this session. Meet you in the next one. Until then, it's bye-bye.